I'm Anil Kumar. Welcome to my series on vectors. Now we will take a few multiple choice questions on the unit 1 of lines where we'll work with vector and parametric equation. To understand all the concepts, I have designed these 7 multiple choice questions. You can always pause the video, copy these questions, try them out, and then look into my solutions. I've also provided a link where we have discussed at length this particular chapter on equation of lines. For all these questions, we are going to consider only one equation that will help you to recall all the concepts and understand the topic better. Question number 1. T equals to 1 represent a line, point with direction, point without direction, or direction from point 1 minus 6. Question number 2. Which of the following points are not on the line R? So 4 choices are given to you. Question 3. Equivalent parametric form of equation is, select the one which is correct. Question number, so let me just push this page a bit here to read out rest of the questions to you. Question number 4. Equivalent Cartesian form of the equation is, question number 5. So let me push it a bit more. Question number 5, 6 and 7 probably are visible to you now. Question number 5. Angle which the given line makes with y-axis is, question number 6. Equation of perpendicular line can be, and equation number 7. Shortest distance of the line from origin is what? These are extremely good questions to practice, and as you can see, you can understand how to write direction vectors, how to write a line in parametric form or in Cartesian form, how to find angle between the line and the axis, and equation of perpendicular line, and also the shortest distance from these set of 7 questions. So I'd like you now to answer these questions and then look into my solutions. All the best. Now let us solve all these questions. You need to consider the vector equation r equals to 1 minus 6 plus t 2, 3, where t belongs to real numbers, to answer all the questions. Question number 1 is, t equals to 1 represents what? Right? Now, since all these questions are related to one particular line, it is better to really understand what this line is. When we write r equals to 1 minus 6 plus t times, which is a scalar multiple, the direction vector t belongs to real number, then what are we trying to say? We're trying to say that the direction of this vector line, direction of this line, which is represented by vector equation, is 2, 3. That means from origin we can go 1, 2 units along the x and 1, 2, 3 units along the y, right? So somewhere like this, let's say like this. That becomes the direction, and we are also given that it passes through a point. Point is 1 minus 6. So 1 minus 6 is, let us say, somewhere here, okay? So we have to draw a line which goes through this point 1 minus 6 and is parallel to the direction vector. So something like this. So let's just sketch one. So that is the line which we will be talking about during our discussion. Is that clear, right? So I hope this concept is clear to you. So that's our xy plane. This is origin, and that's the line r equals to 1 minus 6 plus t times 2 comma 3, right? And this point here is 1 minus 6. Is that clear to you, right? Now when I say if t equals to 1, what does it mean? Let me substitute 1 here. So if I write, let me find r when t is equal to 1. So t could have any real number. That means any point on this line can be defined for different values of t. If I write t equals to 1, I get r as 1 minus 6 plus t is 1. So let me just write 1 now. Okay, 2, 3. And if you do this vector addition, you get 1 plus 2 as 3. Minus 6 plus 3 is minus 3. So we get this vector. Now this is actually a position vector. So on a line, you could say 1, 2, 3. So somewhere here, this is your point. The drawing is not to the scale. So that becomes your position, right? So if you're considering this to be a vector, it will be actually a position vector like this. You will also see that this equation normally will also be written as xy equals to 1 minus 6 plus t, which is scalar multiple of the direction vector 2, 3. Do you see that? So that's another way of writing. So what you get here is basically xy coordinates. So what you get here is basically a point. Let me call this point as, let's say, point P. So in that case, we get a point P, which is 3 minus 3. Do you understand? So you could actually say that this is just a point in the plane, like many other points. This happens to be on the line, that's a different story. But this is just a point. Once we substitute a value t, what we get is just a point, right? And there is no direction associated with that point. It is a point in a plane. So the correct option is point without direction. Now this is a very important question to understand as we move forward. At t equals to 1, or for that matter, at t equals to any value of r, we are only looking for set of points, right? So t belongs to r means set of points. And that leads to equation of line. Individually, each are points. They individually do not represent a line, do not represent any direction. So I hope this point is absolutely clear, right? So from here, let's move forward. If I write t equals to 0, then what? So let this be a question for you. If I write t equals to 0, I get this original point. We normally say x0, y0. Is it okay? But still, it is just a point without specifying any particular direction, right? Question number 2. Which of the following points will not lie on the line R, which is 1 minus 6 plus t times 2, 3, t belongs to real numbers. Now one of the method here is that you could actually substitute different values of t and make a list and check your points. The other method which I prefer is write the equation of line in slope-intercept form. I did not include any equation here to convert this. So I'll take this opportunity to show you also how to write equation of line in slope-intercept form, right? So for the given line, we know that the direction vector m is 2, 3. Now that means that slope of the line m will be 3 over 2, right? So this is the y value. So change in y is 3 for change in x of 2. Now we are also given a point on this line. The point here is, let's call this point P as 1 minus 6. So with that information, I could always write equation of the form y equals to mx plus p. So we have y equals to 3 over 2x plus b. Let's use the point minus 6 for y value, 1 for x value to calculate b. So we get minus 6 minus, let me write now minus 3 over 2 here, minus 6 equals to b. and with common denominator of 2, we get minus 3 minus 12. So the value of b is minus 15 over 2. So that gives you the equation of the line, right? So we can now write down the equation of the line, which is y equals to 3 over 2x minus 15 over 2. Now I'll prefer to use with common denominator of 2. It's easy for calculations, right? So we get 3x minus 15 here, right? So what we will do here is now we'll substitute different values of x and find the values of y. Just compare. Starting from the very first one. So x value, we'll write x values here, calculate y. So if x value is minus 1, so what is y equals to? If I substitute minus 1 here, I get 3 times minus 1 minus 15 over 2, which is minus 3 minus 15, which is minus 18 over 2. That gives me minus 9. So this point is correct. You get an idea, right? So let's put 3 now. So if I write 3 here, so y equals to 3 times 3 minus 15 over 2, which is 9 minus 15 over 2, which is equals to minus 3. So this is also correct. So let's try this, which is minus 3. So we get y equals to 3 times minus 3 minus 15 over 2. And that gives you minus 9 minus 15 over 2, which is minus 24 over 2, which is minus 12. So this is also correct. So the last one here is 7. Let's try that also. So 3 times 7 minus 15 over 2. And that is 21 minus 15 over 2. And this is a positive value. 6 over 2, which is 3. Here we have 2. So this point is not on the line. So I hope the steps are absolutely clear. Let's move on. Here we have question number 3. Equivalent parametric forms of the equation is what? The equation given to us is r equals to 1 minus 6 plus t 2, 3. So that is the equation where t belongs to real numbers, correct? Now, equivalent parametric equation, we know the direction here, m, is 2, 3. So direction could be either that or could be a multiple of this. So in your multiple choice question, it could be some constant times 2, 3 also at times. So let's see the direction first. So we find that these two qualify. We have 2, 3 here. This is not in the ratio of 2, 3. This is also in the ratio of 2, 3. So one of these is the correct option. Now we should check with these equations. Right? We know that the point P, which is 1 minus 6, is on the line. So let's check if this is on which of these lines. That will give us the right answer. Is it okay? So let's check this one here. So if I write x equals to 1, then I get here 1 equals to 3 plus 2t. So we are writing x equals to 1, right? Checking for t value, if that is the correct value. So we get 1 minus 3 equals to 2t. Minus 2 over 2 is t, which is minus 1. So if I substitute minus 1 here, what do I get? If I write t equals to minus 1, I get y equals to minus 3 plus 3 times minus 1, which is minus 6. So that means this is correct. Yes. So this definitely is correct. Let me also check the other equation. Sometimes more than one could be correct. So we can write x as minus 1 again. We'll redo the whole calculation. And so this becomes 1 plus 3 equals to 2t. So 4 over 2 equals to t, which is 2. Now if I substitute t equals to 2, what do I get for y? So I get y equals to minus 10 plus 3 times 2, which is minus 10 plus 3 times 2 is 6, minus 4, not minus 6, right? So this is not correct. So that is the right option. So I hope the steps are absolutely clear. Now let's move on to question number 4. Question number 4. Equivalent Cartesian form of the equation is which one of these? Now I'll take this opportunity to teach you some new methods also. We could solve this using two different methods. One of them is, in question number 2, we applied slope and intercept concept and found the equation of the line as y equals to 3 over 2x minus 15 over 2. So we could actually from here continue and write down the standard form by multiplying everything by 2 and bringing them together, right? So let's do that. So what we did in solution of question 2, we found that y is equal to 3 over 2x minus 15 over 2. Now from here we can get that equation. Perfect. So let's multiply everything by 2. So we can write 2y equals to 3x minus 15. Bringing them together gives us 0 equals to 3x minus 2y minus 15. So 3x minus 2y minus 15 is option D. So that becomes the correct option. Right? So you have to first derive this and then get your solution. This is one way of doing it. Let me show you another way of solving this question. We'll again begin with the equation of the line, which is 1 minus 6 plus t 2, 3. We have already written this in parametric form as 1 plus 2t and y equals to minus 6 plus 3t. Now from these equations, let us isolate t. What is t equals to? So we can rearrange and we can write t equals to x minus 1 divided by 2. And we can also write t equals to y plus 6 divided by 3, right? Now this form of equation, now both are t's, right? Both are t's, and therefore we could write that equals to this. That is to say, x minus 1 over 2 equals to y plus 6 over 3. Do you see that? Now this form of equation is called symmetric form, which we are going to learn in the next chapter. However, it's a good time to introduce you. Now from here, if I cross multiply, so from here let me cross multiply, then what do I get? So if I cross multiply, I get 3 times x minus 1 equals to 2 times y plus 6. So that gives you 3x minus 3 equals to 2y plus 12. Bringing all the terms together gives us 3x minus 2y minus 3 minus 12 equals to 0. And that is 2x minus, this is 3x. 3x minus 2y minus 15 equals to 0. The same answer, right? So you could adopt any of these approaches to solve that particular question. So I hope that helps. So it's a good opportunity to learn as we go through these multiple choice questions. Question number 5 here is, find the angle which the given line makes with y-axis. So this line making with y-axis, that's the angle which we need to find. So I hope the question is very clear to you. What we earlier found is that this direction 2, 3 is kind of like this, going 2 along the x and 3 along 1, 2, 3 like this, kind of like this, right? So our line which we had drawn earlier, kind of like this, has the same angle which the direction m has. Is that okay? Which the direction m has. So this, we could consider this position as 2, 3, right? We need to find the angle which it makes with the y-axis. So I hope the diagram is clear and makes things very simple. So what we can do here is that we can think about that triangle, right? So where this height here is 3, right? And this x position is 2. So you can use tan phi as 2 over 3 and find phi using tan inverse of 2 over 3, right? So that should give you the answer with y-axis, right? So we have shift tan inverse 2 divided by 3 equals to 33.69, which could be rounded and written as 34 degrees. So option B is the right option. Some of you can actually find tan theta, right? So you can find theta here. So you could use tan theta equals to 3 over 2, right? So theta equals to tan inverse 3 over 2. So in that case, phi will be 90 degrees minus this value, right? Minus tan inverse 3 over 2, which you'll again get approximately to 34 degrees. So either way, you could do it. The third option is to use dot product. So y-axis means we are doing dot product of 2, 3 with y-axis will be 0, 1, right? So use the dot product, divide that by the magnitude, which is 2 square plus 3 square. This is magnitude 1, right? 0 square plus 1 square. And then you know what cos theta is. Good. So you could use any of these three methods to find the solution. However, for R2, simplest method is which I've shown you right in the very beginning. Correct? Question number 6. Equation of perpendicular line can be one of these. We are given R, our equation as 1 minus 6 plus t 2, 3, where t belongs to real numbers. Now, how do we find perpendicular line? Now, there are many methods which you could adopt. One of the method could be, since we did question number 4, where we have found the equation, Cartesian equation, right? We have found a Cartesian equation as 3x minus 2y minus 15. We can use this information. So, from question number 4, we have that this r could be written as 3x minus 2y minus 15 equals to 0. Now in lines you have learned that a perpendicular line you could get by flipping these coordinates. So you should get 2x. Bringing 3 here and changing the sign will give you plus 3y. And this could be any point, right? So this could be any point k which it goes through. So that gives you the answer. 2x plus 3y plus k, so it matches with B. So you could do very fast like this, right? Since we have already done question number 4. Let's see if we had this question direct, how are we going to do it? Perpendicular line basically means we are given in this case direction which is 2, 3. So the normal will be, let us say, AB. Some of you will know that you can get normal by negative reciprocal, which is expected answer, shortcut. So we'll just flip this, write 3, 2 with one of them as negative sign. So that becomes the normal. However, we are going to derive this using dot product. How are we going to derive? Using dot product. So I'm taking this extra time just to teach you a few more methods. So we get dot product of m with the normal should be equal to 0. That means 2a plus 3b equals to 0, 2a equals to minus 3b, a equals to minus 3 over 2 times b. Take a value of b so that we avoid fractions. Taking b as equals to 2 will help us get round natural number, right? Integer you can say. So we get 3 over 2 times 2, which is minus 3. So we get our normal as expected, but with different signs this time, which is minus 3, 2. But we could also write this normal as, which is also equal to 2 minus 3. I mean, sorry, 3 minus 2. Is it okay? Both are kind of same thing, correct? So you could use either one of them. I would normally will prefer to use 3 minus 2. We normally keep this positive. Is that okay? So now you know the normal. Once you know the normal, you can find the equation. So that becomes the slope of perpendicular line. So we can say slope of perpendicular line M perpendicular is minus 2 over 3, correct? Is minus 2 over 3. So from the direction you can get slope, and from the slope we can write equation in the form of y equals to mx plus b. So we have y equals to minus 2 over 3x plus b. We can take any point. So let us take point O as origin, right? So that will help us. This will also help us in the next question, where we need to find the distance from origin. So if that is the case, then y equals to minus 2 over 3x, right? Correct? B could be any value. Now you can actually multiply them. So we get 3y equals to minus 2x, and then bringing them together will give us 2x plus 3y equals to 0. We got that equal to 0 since we are taking point as origin, but the point could be any general point. But the important point here is to understand that the direction is defined by these two coefficients, which matches with our option B, correct? So however, this is a long method to understand. In a multiple choice question, you could very easily do it in few seconds as we did. So I hope that helps. So let's move on now to the last question of this exercise, where we are going to find the shortest distance. Now we are at the last question, question number 7. We need to find the shortest distance of the line from origin. So let me again sketch the line here. Right, so now we know how the line looks like. It's kind of like this. We need to find the shortest distance from origin. So that line should be normal to the line. Is it okay? So in the previous question, we have found the equation of normal line also. So let me here give you alternate method. When you're working with the line, which is in this case 1 minus 6 plus t times 2 comma 3, then the direction of this line M is 2, 3, right? What is the direction of the normal? To get the direction of the normal, just flip them. So we get 3 minus 2. Change one of the sign. Negative reciprocal, right? Kind of, I hope you remember. Perpendicular line is negative reciprocal. So that helps you to get the normal very easily, right? So that becomes the norm of the line. And we know origin is a point on this line, correct? So for our perpendicular line, we know slope is what? Slope is change in y over change in x. So we could write that as minus 2 over 3, right? So that gives you the equation of the line also. We could write equation as y equals to mx, which is minus 2 over 3x. Since the line goes through the origin, right, so we are writing a line which goes through the origin. That means b value is 0. Okay? So this gives you the equation of the form. We could write this as 3y equals to minus 2x, or we could write this as 2x plus, bringing it here, plus 3y equals to 0. You get an idea, right? So that becomes the equation of the normal. Right? So what we get here is that the equation of our second line, let me write line 2, this is our line 2, which is normal, is 2x plus 3y equals to 0, right? That is our line 1, which we are saying R. Now, for line 1, we already have found the equation in Cartesian form. It was, let me copy it from where we did earlier. In Cartesian form, we got this equation as So I'm copying this Cartesian form from our solution in question number 4, which is 3x minus 2y minus 15 equals to 0. So our equation of the line which we got in question number 4 is 3x minus 2y minus 15 equals to 0, right? You could refer to question 4 for solution, right, for this equation. So basically we have two different equations, simultaneous equations to solve for x and y. To find this point of intersection, let's call this point of intersection as t, right? So we'll find the value of x and y, and then from the origin we can find the distance. Is that clear? So this is the kind of approach we are going to have. So let me use this part of the page in continuing with the solution. Now these two equations we can adopt method of elimination or substitution. Let me multiply the first equation by, let's say, 3, right? So we'll do this here. So if I multiply this by 3, then I get what? I get 6x plus 9y equals to 0. And if I multiply the other equation by, let's say this one, we are going to multiply this by 2. We'll do it 2 times. So we get 6x minus 4y. Let me take 15 to the other side and write this as 30. Good. Now if you subtract one from the other, if you take away, in that case 6x will cancel and you get 13y equals to 30. If you subtract, right, so get minus 30. Good. So, and which gives you y value as minus 30 over 13. Now y value is minus 30 over 13. What is x equals to? X is equals to, from here we can write x is equal to minus 3 over 2y, which is, so what I've done here is use the x value from this equation. X is equal to minus 3 over 2y, right? So it gives me minus 3 over 2 of minus 30 over 13. So we get x equals to a positive value, 15 times 3, 45 over 13. So this point which we are talking about is, the x value is 45 over 13 and the y value is minus 30 over 13. And therefore the distance OT could be now clearly found as distance d equals to, let me calculate here itself, distance d will be equals to square root of these squares, 45 over 13 square plus minus 30 over 13 square. Is it okay? So you can now use calculator to calculate this value. You could actually take 1 over 13 outside because square of square root, and then within the square root calculate 45 square plus 30 square. So let's do this calculation, find the answer. So we have square root of 45 square plus 30 square, which is equal to 50.08. We'll divide this by 13 to get the answer, which is 4.16. So 4.16 rounds to 4.2, and therefore the answer is C for us, correct? So that is how we are going to do it. I hope with this exercise you now understand how we can solve problems related to vectors. When we are talking about lines, only vector equation and parametric equation. I've tried to give you a good variety, very interesting questions. All of them were linked, and that brings all learnings together. I hope you understand and appreciate it. Well, we have solved all the questions. Now it is good time to recap. So let's get back to our quiz sheet. We started with these 7 questions. Considering the line r equals to 1 minus 6, plus t times 2, 3, where t belongs to real numbers, we need to answer 7 multiple choice questions. Question number 1, if t equals to 1 represents what? Now, we found that this is just a line, right? So on a coordinate plane, we sketched the line which was kind of like this. Direction is 2, 3, right? And a point is 1 minus 6, so the line was kind of like this. When we substitute different values of t, which belongs to real numbers, we get points on this particular line. So for t equals to 1, it's a point on a line, right? So just a point on a line, it does not give you any direction. Question 2, which of the following points will not lie on this? So the idea is, what you could do, you could substitute t equals to plus minus 1, plus minus 2, even 0, and check which points are there. Well, that is a lengthy method because t belongs to real numbers. So the approach adopted was very efficient. We actually learned how to write the equation in the form of y equals to mx plus b. Let me share that page here. And then we calculated each point. Now this is a good approach. And we found that the point D was not on the line. Question number 3. In question number 3, we have to find the parametric equation. Since we know that the direction is 2, 3, so the direction could be scalar multiple of 2, 3, right? So here only values which matched were these two. Now the idea is to check where is this point. Does it lie on that line or this line, right? So 1 minus 6. We tried it out and we found that B is the right option. Then we move to question number 4 to 7. Now these questions involve a lot of calculations. You need to convert your equation into Cartesian form, right? So the method adopted was to find the slope from the direction vector and write the equation. So the method adopted was to find slope m, which will be 3 over 2, and use the point P, which is 1 minus 6, to find equation of the form of y equals to mx plus b. You could actually do y minus y1 equals to m times x minus x1 to get your standard form, correct? And when we did this, we found that option D was the right option. Now this equation actually could have helped you to answer many questions. Now here, we'll now go from 4 to 6. We'll go from 4 to 6. 6 is equation of perpendicular line. So from your knowledge of lines, you know, for perpendicular lines, these coefficients swap with change in sign, right? So if you swap these, so what do we get? We get 2x plus 3y plus anything equals to 0. So that matches with option B. So you could actually save some time here, right? Now, question 7 is also similar since we have a perpendicular slope here and we know that, let's go to question 7. So in question number 7, you get the equation as 2x plus 3y equals to 0 since we are going through origin, right? So 1 is that equation. The original equation of the line is 3x minus 2y minus 15 equals to 0. Solving that, we get point of intersection and then we can use distance formula, right? To get our answer, and the answer was C, which was 4.2. This question here is very interesting. We need to find angle with the x-axis, and as you know, for a line, slope gives you the direction, right? Tan theta. You could also say slope is direction tan theta. So you could actually from here also use tan theta as a slope. But what we find here is the direction vector, which is 2, 3. That means you move 2 units here and 3 up. So that is your direction vector. We have to find that angle. So to find this angle, we named as phi, we could use tan of phi to find the angle, right? So tan of phi, this point is 2 in this direction, 3 in this direction, so 2 over 3. So that gives you the answer, which we found was, I think, 34. So likewise, we could easily answer these questions. I hope all the concepts are absolutely clear. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best.